Hello, my name is Oswaldo Gomez, and I am an MLOps engineer at Roche. So at Roche, we are celebrating 125 years this year, so we're really happy. We're present in over 100 countries. We have more than 90,000 employees, and we are one of the top three biotech companies in the world and a leader in the field of personalized medicine. So at the Solution Center, at the Roche Global IT Solution Center, we are in Poland, Canada, and Malaysia, and we are over 700 employees, full-time employees, and 5,000 contractors. We are basically the headquarters software development for the Roche Group. So why should we care about MLOps? 98% of IT leaders believe that MLOps will give their company a competitive edge and increase profitability, and at least half the models will not be fully deployed into production by 2022, according to Gartner. And this was actually written in early 2021. So yeah, it takes some time. Interest is growing. So Roche has a very ambitious goal of delivering twice as many medical advances to society at half the cost. So it only makes sense to use and leverage artificial intelligence algorithms for example, in whole slide image analysis, it offers the potential to bring important new information to pathologists, and this can actually profoundly impact patients. So MLOps actually requires a complex blend of skills, and you need data engineers, data scientists, DevOps engineers, and data engineers together with like software engineers, ML architects. You need to prepare for production, deploy to production, monitor, and further develop the model. So it's complex. And usually this is traditionally done in Jupyter notebooks, where you have some offline data, you prepare the data, you train the model, you evaluate the model. Once it's trained, you just send it to somebody, and that somebody creates an API for you and exposes the model, and that's it. That is manual, script driven, and there's a disconnect between ML and operations. So there's infrequent release iterations, and of course after level 0, according to Google, there comes level 1, and this goes from delivering a model to delivering a model producing pipeline. So there's a big shift here, because now you care about reproducibility, you care about being able to containerize the steps via components. So each one of these could be a independent component that's running on a Docker container. You have everything up to here is the ML part. Then the ops part is divided by you push the code that generates a pipeline. You push that into a Git repository, and then you can use GitOps to deploy the pipeline into staging, pre-production, and production automatically. And this automation will actually come in level 2. But ideally, you this is the important part. You have a model producing pipeline. So how do you create pipelines? Of course, there's many ways, and I think the canonical stack for MLOps is in the making. So I'm going to talk about one open source tool that it's growing in adoption, and it's called Kubeflow. And this is directly grabbed from the Kubeflow website. So Kubeflow project is dedicated to making deployments of machine learning workflows on Kubernetes simple, portable, and scalable. So, and yeah, maybe the last part is anywhere you're running Kubernetes, you should be able to run Kubeflow. So Kubeflow is about composability through components. So this is quite interesting because these individual boxes are components, and each one of these components, you can actually create a component by decorating a Python function and calling that a component. So you can create components like this, or you can create components using containers. And this is a very good approach, because then you can reuse a data ingestion component that has nothing to do, that's not specific to system one, and you can potentially use it in a different pipeline. So this is great. You don't have to repeat yourself. And of course, then comes the portability. You can run this anywhere. Right now, let's see where we are, but we are deploying this to our laptop. Of course, there's many manifests here, and these are the pods, and many of these pods are already running. Some of them are creating. Uh, as you can see, it's been under a couple of minutes only, so we're good. We'll come back to this in a couple of minutes. So yeah, Kubeflow is about portability, but also about scalability. And this is actually interesting. I was talking to one of my colleagues, and he told me we already have a model in production, or models in production. They run of a big 32 core machine that's on-prem. I have two of them, and this is great, but there's, it doesn't scale very well. There's actually peaks of traffic. It's not like there's big spikes and there's nothing, and this is not scaling well. And by grabbing this information and using, the native Kubernetes resources and tools, and using specifically KF serving, we were able to auto scale, to use the principles of auto scalability to like serve hundreds, actually millions of predictions per minute. And of course, we went from having 0 pods to having hundreds of pods. And so we actually ramped up to having 50 nodes in a matter of minutes. And these 50 nodes, basically, we had 400 cores making inferences. And I just, clipped that to 50, but we could have let it run to like 100, but we just want to keep it safe. And at the end of the day, we were able to get millions of predictions, and we calculated that it will actually give us billions of inferences in a couple of days at a cost of around thousands of dollars, and not. So you could think about billions now, and this is the power of using things like Kubernetes and bringing the power of the cloud, the power of Kubernetes. Then on top of that, you use Kubeflow, KF serving, and when you combine all of these things, you can actually do great things. So before I forget, I will show you the references here, and I will now go to the repo that I prepared for this talk. I will be sharing the link to this repo. So this contains just the commands that I used to create the kind cluster. This kind cluster has it works with Kubeflow, so you will not find any issues. I will actually exit out right now and just briefly show you the README file. This is not this. I have a couple of sub repos that I will show. Okay, so the README is quite small. One of the things that you need in order to run pipelines using the manifests repo. So Kubeflow, has like almost push button ways to deploy into the cloud, but I want to show the sort of like the open source way to deploy Kubeflow. And of course, there's a couple of things that you need to be aware of. So for example, one of them is the Docker, the container runtime executor by default is Docker, but in kind, it's actually in kind Kubernetes version 19. You need to set this to PNS, otherwise the pipelines will not run. So this, takes a couple seconds, but just saving you some time on the things that I noticed that were not working out of the box. And of course, since we will be port forwarding, I didn't want it to deal with anything other than like my local computer and port forwarding, just for keeping this simple. In production, you will have a URL and you will not have to port forward or do anything like this. But right now we are working from the local computer. So after setting the executor, we will also change this config map, the knative in the knative serving namespace. The config map is called config domain, and actually a shout out to my colleagues, to my colleague Aline Spinu, because he actually, I was like, wait, I cannot do this. Like, what am I missing? And he pointed me to this config map. So thanks a lot. Uh, and yeah, let me just change this. So this way, instead of deploying to example.com, my inference endpoints will now be intra-cluster communication, and I can just port forward and actually curl one of the endpoints that I will be deploying as an example. So this is all in the README. Okay, so I edited that, grabbed that. Let's go back to K9s. K9s is just a nice way to explore Kubernetes resources. So some of them are, most of them are finishing, pod initializing. Should be fine. I will go to service now, to service, and just Istio Ingress Gateway will be the how we will port forward here just to have a look at Kubeflow UI. Port 8080 will go to my local host. So that is done. Now, if I go to localhost 8080, I will be looking at Kubeflow. The username is user@example.com, and this is just the default username and password. That is all clearly defined in the manifests repo that I added to the repo that I will be sharing. So we will see some errors because some of the things are still being deployed. The pods are initializing, so that is containers are being created. You can describe what's going on, and you will see that probably it's getting pulling image. So that's normal. And I will X out here, and let's see. So we have here notebooks. We have like you can create your Jupyter notebook. We have tensor boards, volumes, models. Um, Models still not available. Experiments. This will take a second, but experiments are AutoML are actually quite interesting because if you're a data scientist and you want to find the optimal set of hyperparameters, normally you will do this in a Jupyter notebook or using a for loop or something, and it takes some time. But the great thing here is that you can do that in parallel. So you can parallelize the trials. You can set, for example, if you're trying to maximize or minimize a specific metric, um, you can actually use different search algorithms like grid, hyperband, it gives you incredible flexibility, the hyperparameters that you're trying to maximize. And then you hit the create button and the trials will start, or you can configure that via a YAML. You have the pipelines here, you have the runs, the executions. You can even manage contributors here. So you can basically share a Kubernetes a Kubeflow instance among multiple users, and you can choose who has access to what, which is of course very useful. Let's look at this. This is probably starting right now. Now we have the pipelines, and I will show you one pipeline. And before I show you the pipeline, I wanna, since we have limited time, I will go to the models, and I will deploy a model just for illustration purposes. So this is the model. So, right now we will see the pipelines, but the pipelines produce a model, like I said. And once you have the model, you save the binary, the model, you save it somewhere. Right now, I'm grabbing a model that's an example that it's already deployed it's stored in Google. You can save it, it could be in a S3 bucket or wherever you like. So this right now is deploying, and you can see how nice we will get details, log, the YAML file. So for now, I will show you very quickly the pipelines, and then we will go back to see an example. I have to choose an experiment. That's why I just went back. But here, when I run this, we will see that this will create 3 containers. So I will go here and open up another K9s. and you can see that it created Kubeflow user example. These are three different containers that are getting created right now, and in a moment we will actually be able to see them in the UI. So you can click here, and you can see that we have a write numbers, repeat line, and a split line. So if we click on them, we can see the message that it's getting created. But it's very important when you create when you have a model, you want to know the inputs and the outputs that you use to make the inference at the time. You want to have explainability, but reproducibility as well. So here it gives you details about what's going on, the volumes, the logs. So here you can actually see the logs of the container, which is very useful. So here I will go back, and you can see that these are initializing, this is pending. So yeah, this will probably in a couple of seconds will finalize, because these are very simple examples. They're not doing anything complex. Can actually split this. And by the way, you need approximately 20 gigabytes of RAM to run all the Kubeflow. You can select different parts of Kubeflow to deploy with less RAM memory, but for now, this is it. So yeah, you can see here that it is finalizing, and you will be able to see here, everything green whenever it finishes. You can imagine this doing some complex work for you. Here's just a demo. Um, the model side, I think it's the interesting part. The last part I will touch, and then I will thank you all. And in the models, let's go back here, and we already have here a pod that is making inferences for us. So right now, what we can actually do is port forward, port 8081, because I'm already using port 8080, and I already have here a sample command that I can send. So this already received I basically send it a curl command, and we will able to see that I received the 200, and in the curl I got the model name, it's sklearn iris, and I have an ID and the parameters, and I have basically my prediction here is 1 2. So I could we could see the sklearn, sorry, not the sklearn, but the iris.input. And of course, this is the input that the model expects. And if I send it again, I will just obviously get the same response. And you could see here, if we have any error or anything. This concludes my demo. I'm over for a couple of minutes. So thank you so much, and have a wonderful day.